So we start. Good afternoon, everyone. It is a great pleasure to welcome you today in the webinar for 5G network security through the lens of SAND5G. As you all very well know, as 5G adoption accelerates across Europe, new cybersecurity challenges arise, challenges that call for innovative risk assessment tools, effective real-time threat mitigation strategies, and stronger cooperation between public and private sectors. Today, we're honored to host distinguished experts from academia, national regulatory authorities, and industry who will share their insights on addressing the security requirements and strategic implications for next-generation networks. I will not take much of your time, and I will call to the floor Professor Paris Kitsos to provide us an introduction on the SAND5G project. Professor?
Yes.
Okay.
Okay.
Yes, we can see the presentation and we're
good afternoon, ladies and gentlemen. Pinet, thank you very much for this webinar. I will give you the basic of the SAND5G research project. So, SAND5G project is funded by Digital Europe program under the Cybersecurity and Trust Call. The duration of the project is 36 months and it started in January 2024. The project consortium consists of 7 partners, 3 companies, Sphinx, O2 Technology and Wings ICT, 1 university, the University of Patras, the Electrical and Computer Engineering Department of the University of Patras, 1 competence center dedicated to future network, PNET, located in Patras, and the 2 Greek authorities involved, and they are the Hellenic Authority for Communication, Security and Privacy, and the second one, National Cybersecurity Authority. Here is the summary of our project. 5G networks, future network, are essential to the European digital transformation. So those networks actually are the backbone of critical systems and services. In order to achieve high level of security along with privacy and trust, advanced technical measures and close cooperation among all stakeholders are required. So operators, national authorities, researchers, and industry experts must work all together to build a robust defenses. Here are the challenges of our project. The first one, the EU and its member states must adopt a comprehensive cybersecurity strategy. In order to do that, SAND5G will deliver a platform for 5G security assessment, monitoring, and risk awareness. The second one, strengthening overall resilience beyond cyber supply chain attacks, is essential. SAND5G will develop a risk platform combining asset and efficient architecture and physical data. The challenge 3, member states should avoid strategic external dependencies and vendor lock-in in ICT services. SAND5G, in order to do that, offers a model-driven approach, secure, flexible, and components replacement. And the last one, highlight the strategic and operational importance of the European Cybersecurity Competency Center and the National Coordination Centers. In order to do that, SAND5G will connect stakeholders to enhance knowledge and capacity building. The primary goal of SAND5G is to provide a platform for risk and impact assessment theory for 5G. This platform is designed to support first 5G stakeholders in strengthening the security of their security and of their systems. Second, national authorities and regulator in assessing security measures and ensuring alignment with national cybersecurity strategies, European 5G policies, and the proposed European 5G security toolbox. Then I will provide some basic about the proposed architecture. The SAND5G project aims to build a platform that delivers both technical and financial risk assessment for 5G stakeholders. In order to ensure that infrastructure and services comply with national cybersecurity strategies and telecom security frameworks, and then the platform will enable continuous 5G system monitoring and integrate security operations and automated response capabilities in order to provide efficient management. The proposed architecture consists of four main parts. The first one, the security operation, protect the targeted 5G system and conduct real-time technical and financial risk assessment and reporting. The second one, the model part, enable a customizable security platform capable for supporting 5G future network. Then the knowledge and capacity parts offer supportive services that go beyond the boundaries of 5G system or infrastructure and target providing the skills, awareness, collaboration of the overall European 5G ecosystem. Finally, our project will carry out some pilots in order to test and validate the proposed system. The first step is the operators. The University of Patras, in collaboration with Sphinx and PNET, is responsible for this work. The aim is to ensure infrastructure compliance with national policies and regulation and evaluating the security impact of new components in 5G system and networks. Then, WINGS and OQ technology are the vertical providers that will evaluate some security challenges incorporating 5G technologies to their infrastructure and services. They also will develop models, playbooks, some trainings aligned with national and European cybersecurity frameworks. Finally, the regulators and the two national authorities, the National Cybersecurity Authority and ADAE, can support security measures across infrastructure, supply chains at the national level. Thank you very much. If someone needs more information about SAND5G, we can discuss offline or during the Q&A session today later today. Thank you.
Thank you, Professor. Now let's move to the keynote speeches. And we start with Mr. Hadjiloizos, with the capacity of Head of Network and Infrastructure Security Department of the National Cybersecurity Authority. Mr. Hadjiloizos, the floor is yours.
Thank you very much. Thank you for having me here. Let me share my presentation. Okay, do you see that?
Yes, we can see it.
All right.
Yes.
Okay. Again, my name is Spiros Katsilozos. I'm in the National Cybersecurity Authority, and I'm head of the unit of network cybersecurity. And my presentation relates to the 5G and telecoms. So let's start. The 5G key benefits. We'll see the 5G key benefits, the new landscape and new challenges, and the EU legal framework. In the second one slide, we see that in this figure, we see how the 5G network changes the whole industry. We see the physical infrastructure, and we see that it changes the cities to smart cities, the factories to smart factories. We have here the autonomous vehicles, the smart grids, the energy smart grids, etc. So moving on, this revolution begins with the ultra fast speeds, the lower latency, the massive device connectivity, and the increased capacity. And the second key benefits is the network slicing, the improved reliability and availability, the enhanced user experience, and the energy efficiency. Now, what are the challenges of the 5G in terms of the cybersecurity? We have the increased attack surface, the new evolving threats, and the increased responsibilities and demands of on the national cybersecurity authorities. If we examine the increased attack surface, we see that this is because of the massive device connectivity, the edge computing, the network slicing, the software-based infrastructure, and the untrusted components and supply chains, and supply chain risks. The new evolving threats are because of the distributed denial of service, the IoT exploits, the side channel attacks, and the hybrid threats. So if you want to see an overview of the legal framework in EU, the main thing that we have to address is the 5G security toolbox. This is a non-binding guideline for all the member states, and this is a guide to mitigate risks. And again, this is a non-binding one. We have also the Cybersecurity Act that introduces an EU-wide cybersecurity certification framework for ICT products, services, and processes. And we have the NIS2 directive, for which, among others, expands cybersecurity obligations for telecom providers, including incident reporting and risk management. And also we have the revised Telecom Code, ECC, that mandates security audits and cooperation between the national regulators. Okay, what are the increased responsibilities and demands on national cybersecurity authorities? And we have here that they have to implement and oversee the EU 5G toolbox, develop security certifications for 5G components and services aligned with the EU Cybersecurity Act, and they have to deal with cross-sector coordination, cope with public awareness and preparedness, and deal with the lack of specialized personnel. Now, how to enforce, what is the enforcement of challenges in the member states? They have limited technical capacities, some of them. They have to balance security, competition, and innovation within the internal market. And also, they have to vendor risk management under the new geopolitical pressure. Here we have a table with comparison of EU approach and US approach. And as you can see here, in EU approach, we have to deal with so many authorities and states to end up in a directive. And we have a legal framework that is not all the time binding. For example, the toolbox is not binding in relation with the national strategy to secure 5G in the US. And also in terms of vendor restrictions, we have here in EU 11 states that have partially banned some vendors. From in the other side, in US, we have full bans of Huawei and ZTE. Here in the European Union, in terms of agencies, we have ENISA, and also we have the national regulators. In US, we have CISA and FCC. This is the main differences between the EU and US approach. And in this table, we see how difficult it is to be efficient and in time. So if you ask what might be the main ingredients for any type of solution, and especially in cybersecurity, I would say that this is that collaboration is the main word. But collaboration with in relation with trust building, in relation to awareness and information sharing, in relation to training and education, and last but not least, all these have to be done with an efficient way. And I think that I'm in the time frame that you asked before. And thank you very much.
Thank you, Mr. Hadjiloizou, for the insightful information you provided us. So I would like now to move on to Mr. Stathopoulos, which is a security expert and head of incident reporting from the Hellenic Authority of Communication Security and Privacy. Mr. Stathopoulos, the floor is yours.
Good afternoon. Thank you very much. Share my screen. Can you see that? Yes. All right. I would like to.
Yes.
Yes.
Yes,
okay.
can see.
My name is Vasilis Stathopoulos. I work as a security expert in ADAE. ADAE is a communication security and privacy authority in Greece. I also participate in European fora. Currently I'm a vice chair in ECASEC, which is a collaboration of member states discussing matters related with cybersecurity. And today's presentation is about the 5G cybersecurity toolbox. A small definition. What is It's a coordinated risk assessment and mitigation framework. It's essentially a collective framework developed by EU member states in order to tackle the shared risk posed by 5G networks. Rather than each country active alone, they offer a harmonized, flexible approach for risk management and mitigation that actually reflects the unique challenges in 5G technologies. It was established in 2020, but I would like to make a small recap about the history. So in 2019, ENISA with the Commission published a report that it was related to the risk assessment. It is named as a coordinated risk assessment on cybersecurity in 5G network. So this risk assessment actually identified the main risks and threat actors and also the sensitive assets and the main vulnerabilities. Also, it's a collective work of all the member states. And based on this document, it was published on January 2020, the 5G toolbox that was under the leadership of the NIS Cooperation Group, which is also a body that is defined within the NIS 1 and now in NIS 2 directive, responsible for the strategic collaboration among the EU countries for network and information system security. The purpose of having this 5G cybersecurity toolbox was to address the security risk in 5G networks across the European Union, as I have said, and manage and mitigate the new and complex risks introduced in 5G. The idea behind that is that 5G is going to and is underpins a range of critical services, from healthcare to power grids, to transport, to emergency services. So it's vital to ensure that all these networks is going to stay there and resilient, reliable, and secure. And the core principle, it's a common approach while respecting national sovereignty. It means that actually it's not something that the 5G was developed, let's say, jointly by the European member states and the NIS Cooperation Group, but each country can choose to implement part of it, all of it, or some security measures depending on the national circumstances. Increasing dependence on 5G. Why the toolbox was created? I think I have already said that, is to increase the dependence on 5G networks for critical infrastructure. And new security challenges also is another reason for the why, unique for the 5G architecture. First of all, virtualization of network functions. As well, no 5G moves away from traditional hardware-based infrastructure and embraces virtualized functions, which can be dynamically managed by also open up new attack vectors. Also, the software dependency is very important because the shift to software-defined networking means vulnerabilities in code can have far-reaching consequences. Also, the supply chain complexities are increased. 5G networks rely on components from multiple vendors across the globe, which increases the risk of supply chain. And also, in general, the attack surface with more connected devices and distributed architectures. So the main part of the toolbox is analyzed into three different, let's say, parts: in the strategic measure, the technical measures, and the supporting actions. Strategic measure is more strategic. It deals with governmental oversight, with assessing third-party suppliers, for security risk, encouraging a diversified vendor base, which is very important. And also the technical measures, it's defines baseline security measures, mechanisms for real-time security monitoring, threat detection, and also some supporting actions, mostly concentrated on standardization of defining certification schemes for equipment, but also for 5G in general. Going through that in a little bit more detail, I will say that strategic measures, the first two strategic measures have the aim to strengthen the regulatory powers, strengthening the authorities and the power that they have in order to oversight and investigate the providers' 5G networks. Then the third one is the risk assessment of suppliers. We have a lot of restrictions for high-risk suppliers. The fourth one is controlling the use of managed service providers. Managed service providers are actually providers that are able by remotely accessing and provide management to telecommunication providers. So the role is very important for this reason. MSPs often have deep access in network operations, so this measure ensures their roles are carefully managed and subject to stringent oversight. So for the security measures 5, ensuring diversity of suppliers for individual MNOs means actually to avoid dependence on a single provider. For this reason, countries are encouraged to build a multi-vendor environment and enhancing resilience and competitive innovation. We have the strategic measure 6, strengthening the resilience of national level. This involves national strategies to improve overall cyber resilience, including incident response capabilities and long-term planning. And the strategic measure 7, which is actually the idea that EU tracks foreign companies that try to buy into important parts of European 5G systems. And also the strategic measure 8 is maintaining and build diversity and EU capacities in future network technologies. Regarding now the technical measures, and technical measure number 1 is mostly baseline security requirements. It's the minimum technical security standards that all 5G networks must comply with, forming the foundation of network protection. The technical measure 2 has to do with ensuring and evaluating the implementation of security measures in existing 5G networks standards. It's actually making sure that mobile operators and the companies that provide their equipment and software are really following the security rules that already exist in the official 5G standards. The technical measure number 3, which related with access control privilege management, means actually strict access control, segregation of duties, update and continuously enforce and stuff like that. Technical measure 5, increasing the security of virtualized network functions, which means that mobile operators should use best security practices when running virtualized network functions. And technical measure 5 is secure network management and operations. This is related with NOC and SOC, Network Operation Center and Security Operation Center, to be located, if it's possible, within their country or at least within the EU. Technical measure 6 is reinforcing physical security. This is more related to the security of the base stations and the multi-access edge computing, which is actually the idea of moving closer to the base station and to the user, the intelligence. So especially when these are deployed in high risk and sensitive locations. Moving forward, we have technical measure number 7 is reinforcing software integrity and update and patch management. Software integrity, actually, you have to maintain a level on the software quality in order to be sure that never the software will altered without you know that, and check about that. And technical measure 8 is raising the security standards in suppliers' processes through robust procurement conditions. This means actually that asking suppliers to follow high security standards, it's very important. Also requires suppliers to prove the quality and security of their products, and also making sure that security is built into the equipment from the beginning, designed by the beginning, not added later. Technical measure number 9 is using EU certification on 5G network components. The idea behind that is that the European Commission should consider creating EU-wide certification schemes for key parts of the 5G network and also for customer devices like the electronic SIMs, the electronic SIMs. Regarding technical measure 10 is also using certification for non-5G specific ICT products that are going to be connected within the 5G network, just like our various connected devices or the cloud services. And finally, reinforcing resilience and continuity plans, which is also very important. What is the progress? I mean, this was established, all the idea was established in 2020. We have a progress report since 2023 and from the Commission, which says that the full implementation deals only for 30 member states that have implemented the high-risk vendor restrictions. The partial implementation deals for 14 member states that have established enhanced security requirements. And the overall progress touches about 24 member states that have incorporated toolbox measures into national legislation. I have also a map, a heat map, let's say, that gives, it's a little bit blurry, but I think we can see that, that shows how many have implemented from the member states, how many are in progress, and how many are planned and no action taken yet. Maybe this table has been altered, but it gives a hint about what the action's about in the European Union. And also we have this for the technical, for the technical measures. There's a lack of progress in technical measure number 2 and technical measure number 3. There is also a case study that has been hosted in Germany. It's from Germany that they have implemented an IT Security Act on May 2021. Actually incorporating the 5G toolbox, and the idea behind that is that they establish technical organization strict scrutiny of critical components. All critical parts of the network must now pass through strict assessments in order to ensure they meet high security standards. Also, operators of critical infrastructure should notify the Federal Ministry of Interior before the first time use any critical of the component. Trustworthiness declaration for suppliers. Suppliers are required actually to approve their reliability and compliance, adding a legal layer of accountability. Federal approval required for critical components. This means that before critical infrastructure is deployed, it must be reviewed and approved by national authorities. And multi-layer security architecture requirements means that network must be designed with layered defenses, ensuring redundancy and resilience at multiple layers. One view for the SAND5G contribution. It is an advancing toolbox implementation through enhanced risk assessment. This enhancement in risk assessment means that leveraging AI, the SAND5G provides predictive insights that help identify and respond to emergency threats proactively. Security monitoring, which is real-time impact assessment platform. The aim here is to provide a platform that monitors the 5G network 24/7, providing instant feedback on security events and allow network operators to respond immediately to security issues as they arise. Information sharing means that it aims to encourage cross-border collaboration between different countries and also help the countries share security information and threat intelligence. And finally, testing and evaluation means that aims to the toolbox to ensure that the toolbox measures are not only theoretical, but are validated through real-world testing and demonstration. Thank you very much.
Thank you very much, Mr. Stathopoulos. While you were presenting, you and Mr. Hadjiloizou, you had a question from the people that are watching us.
Okay.
And it's quite an interesting question, and I would like to address it to both of you, Mr. Hadjiloizou and you. The question is as follows. The NIS directive is binding, and it actually has been transposed as a law. How does this affect 5G security? So who wants to answer it first?
I can ask you if you wish. Mr. Arabadzis said that NIS2 directive is binding and has been transposed into the national law. This is true, and Mr. Arabadzis tell that very nicely. In the table that I have shown you, there was two things: binding legislation and non-binding. In the binding was the NIS2, and in the non-binding was the toolbox. Of course, in our legal system, we have incorporated NIS2 under the law 5160 2024, and this gives us the general rule on how to cope with the cybersecurity. Especially in the Article 21, we have measures that we can that are horizontally for all these sectors, and we are in collaboration with ADAE to see how to clarify specific measures for 5G. This is that I can say about that.
Thank you very much, Mr. Hadjiloizou. Mr. Stathopoulos, would you like to add or comment anything regarding this question?
Yes, I would like to say that traditionally was, I mean, from the beginning of these cases, there was the ECC code. Previously was the ECC code in the telecommunication era that imposes a number of security measures, irrespectively of if it's a 5G or it's a 4G, of any applied technology that is used. So all the member states have the mandate to investigate and to oversight these networks, also the 5G network. Then it was repealed. I mean, the ACC code was repealed, and then NIS2, because of the NIS and then NIS2. And also the NIS2, as the previous speaker said, defined a number of security measures that have already developed in detail from the European Commission in an implementing act, without discriminating if it's going to be 5G or 4G or any fixed network. So all the member states have the mandate to investigate and to audit the security measures. Traditionally, ADAE has already directives and second-level legislation that is able to investigate, and we're doing that. We audit the providers, all the different parts of the networks, either it's a 5G or 4G or fixed network, as I said before. And from now on, with collaboration with the National Cybersecurity Authority, we will do our best also to do the same job and audit these providers.
Okay, thank you both very much for the answers. Now, moving to the presentations, let's go to the technological approach, and I would like to welcome Mr. Konstantinos Poulios, Chief Technology Officer at Sphinx Technology Solutions. Konstantinos, the floor is yours.
Good afternoon, everyone, and thank you for joining this webinar. Today I will give you a small presentation on the SAND5G platform. Let me share my screen. Please let me know if you don't see.
Yes, we can see it.
Okay, great. Thank you. So basically, 5G technology is becoming more complex, as everyone mentioned already, which increases security risks. The SAND5G project will deliver a platform to help analyze and address these risks. This platform provides tools to assess security, monitor for threats, and even respond to incidents. So this presentation will explain how the SAND5G platform works and why it's important. Basically, the goal of the SAND5G platform is to bring together two distinct technologies to create a more secure 5G environment. It achieved this by integrating advanced cybersecurity tools and techniques directly into the 5G technology ecosystem. You've seen this diagram before, but I will elaborate a little bit more on this. Everything began with the initial concept of SAND5G and the conceptual architecture that you can see on the screen now. Here you can see one of the conceptual architectures that we finalized after carefully analyzing the capabilities and requirements for both 5G and cybersecurity. So now let's walk through some of the key ideas behind this architecture. We'll start with the models, which cover every possible model that we might need from a security standpoint, such as Cacao for incident response, to models specific to the 5G ecosystem. Cacao is a specification that is probably going to be standardized, and basically it is used to create playbooks, so certain attacks can be very well documented and shared across multiple cybersecurity systems and components. Next, we have the security operations, which include every security action and process. These operations were broken down to smaller critical components that I'll dive deeper in the upcoming slides. Now, next is the 5G ecosystem, covering both the network infrastructure and the network services that are vital parts of the platform. And finally, but equally important, is the knowledge and capacity, which includes the education and training, experimenting, consulting, and mentoring, and much more, all of which are essential pillars supporting the SAND5G platform mission. Now let's dive deeper into the detailed architecture of SAND5G. As you can see, it's a bit of a complex design that goes into extensive detail for each individual component. I will try to make this a little bit simpler. So let's zoom out and take a look at the overall architecture of the SAND5G platform. Let's start with one of the most important parts, the 5G ecosystem. This ecosystem consists of many different devices connected to the network, constantly sending and receiving data. Using security tools like honeypots and Snort, we can collect logs, traffic, and other important information that we need based on some predefined rules. These collected data are then sent to the privacy assurance and monitoring components for evaluation. The next major part of the architecture is security and privacy assurance, which is responsible for the platform's risk analysis and management and assessment. When security and privacy assurance receives data from the 5G ecosystem, it performs various types of analysis utilizing knowledge from pre-trained machine learning models to help user and entity behavior analytics, WEPA basically, and determine if everything is operating normally. It also leverages cyber threat intelligence, incorporating tools like meter attack to enhance its assessments. Once all evaluations are complete, it is if an incident is detected, security and privacy assurance will immediately notify the automated incident response system to initiate the next steps. Now we have reached another critical part of the architecture, which is the incident response. Incident response plays a vital role in SAND5G as it can mitigate identified vulnerabilities and also is responsible for triggering the alerting and reporting system. The automated mitigation processes are based on Cacao playbooks that I mentioned earlier, which can also be authored by the relevant authorities to ensure that the responsible personnel are alerted immediately. This assists on mitigating the attack as soon as possible. Another important goal set for the SAND5G project was to promote a proactive approach to security. In order to achieve this, SAND5G includes a cyber range system, which gives stakeholders with different responsibilities the opportunity to train on critical topics that can help prevent security incidents before they occur. The courses are fully interactive. They allow users to learn easily by watching videos, answering some quizzes, performing interactive exercises through emulated environments. And additionally, they can assess their knowledge by performing some assessments that we have. SAND5G provides also a user-friendly UI for stakeholders to stay updated on the security status of their systems. Through the UI, stakeholders can view dashboards that display the overall health of the system and take specific actions such as manually running an analysis or an assessment. Additionally, SAND5G enables authorities to create Cacao playbooks directly through the UI, which are automatically executed in the event of an incident. Now that we have seen the architecture, let's take a look at the functionalities available through these components. First is the vulnerability assessments. SAND5G performs vulnerability assessments by scanning the infrastructure for weaknesses. This includes identifying software flaws, misconfigurations, and other potential issues that could be exploited by attackers. Next, we have the security monitoring, which SAND5G continuously monitors security events across the 5G network to detect suspicious activity and potential threats. This real-time monitoring of the network is crucial for early threat detection and quick incident response. Next, it comes to incident response. The system can automate responses to certain types of security incidents. This automation significantly improves the speed and efficiency of threat handling, helping to minimize damage or disruption caused by attacks. Next is regarding reporting. Again, SAND5G offers notifications and detailed reporting features to keep all stakeholders informed about security events and the overall health of the 5G network. And these reports, most of the times, are essential for audits and ensuring compliance. Next, we have the security and authorization. The platform includes mechanisms to control access, ensuring that only authorized users can access its tools and data. This involves strong authentication to verify identities and authorization to control what actions each user can perform. Next, we have the penetration testing. Penetration testing results are embedded in the platform and in correlation with other data can provide more accurate analytics. Finally, we have a user-friendly interface. This platform provides a very user-friendly dashboard that makes it easier for the way to users to interact with security tools and data, which is also very critical for efficient operations. And finally, of course, we have a lot more other functionalities that I don't have enough time to share now, but of course, you can feel free later to discuss further. Now that we know what SAND5G offers, let's take a look at the key benefits we gain from utilizing SAND5G. First is obviously the enhanced 5G security. The platform provides a comprehensive approach to securing 5G networks and services. It's specifically designed to address the unique security challenges that come with the ever-evolving 5G technology. Next is the proactive risk management. With tools like vulnerability assessments, penetration testing, and cyber awareness training, the platform enables organizations to identify and mitigate risks before becoming serious issues. This proactive approach is critical to minimize the likelihood of successful attacks. Next, in terms of improved collaboration, the platform makes it easier for operators, authorities, and security experts to collaborate and share information. This collaboration, which is required by the project anyway, is vital when it comes to mitigating attacks and staying informed about the security status of the network. Next, when it comes to efficient threat detection and response, thanks to continuous monitoring and the automated instant response capabilities, in addition also to the machine learning integration, the platform is enabled to act faster and more effective to certain security threats. This helps minimize damage and ensures the services continue to run smoothly. Platform supports the regulatory compliance as well because it helps organizations meet relevant security regulations and standards, ensuring compliance with legal and industry requirements. This reduces risk for companies and helps them stay ahead of regulatory challenges that they face. And finally, real-world application. This platform is not just theoretical. It shows how these security solutions can be applied in real-world 5G scenarios. And this ensures the tools and strategies are practical, effective, and ready to handle operational needs as they arise. Thank you very much. That was all from me.
Thank you, Mr. Poulios. So we're moving now to Mr. Alexandros Katsarakis, R&D Project Manager in Sphinx Technology Solutions. Mr. Katsaraki, the floor is yours.
Hello, can you see my screen?
Yes, we can see it.
Perfect. Good afternoon, everyone. My presentation focuses on the application of machine learning, particularly user and entity behavior analytics, also known as UEBA, for threat prediction and real-time impact assessment within the SAND5G project. So 5G networks present a significant leap in complexity compared to previous generations that we already had, like 4G. And this complexity demands, of course, more advanced and sophisticated security approaches. While machine learning plays a vital role in enabling proactive threat detection by analyzing vast amount of network data that are being produced by the 5G ecosystem. That's why we will need something like UEBA, which is crucial for threat prediction and impact assessment, since it establishes a baseline of what's a normal behavior and identifies deviations from that behavior in order to to indicate malicious activity that may happen. So here I have set up an example of how humans already do this thing. So let's say that, for example, you have a coworker named Mary, and she's always happy and cheerful, and she always greets enthusiastically, and she's doing it for many days in a row the same way. And of course, we react by saying always happy to see you or something similar to that. Then on a particular day, Mary comes into the office and just says hello. And immediately you understand that something is going wrong with Mary, and that's not her usual behavior. And this makes you ask Mary if everything is correct, because you understood that she changed her behavior. And it's not the behavior that she normally has in her everyday life. This is the kind of approach that machine learning, and specifically UEBA, follows. So it sets up a baseline for normal behavior for someone or something, and if that deviates from what's known for that particular user or device, it will understand that something is not correct. Now, let's move on to a more specific example to 5G. So let's say that you're working on a university and you typically log into your university computer around 4 p.m. every weekday, and you use it for about an hour, and mainly you're visiting university websites or university-related websites in general. Then one day you log into someone logs into the computer at 2 a.m. from a different country, or it tries something different, like accessing the private university networks, that something that normally you are not doing. This will, of course, trigger UBA, since it knows your baseline, it knows how your behavior, how you work, and it will immediately understand that something is going wrong, and it will evaluate it as a potential threat or an issue that needs to be addressed. Now, UEBA is used to identify anomalous behavior, as was mentioned, but it doesn't do it only for users. It also do it for network entities. These entities can include devices, applications, or even network functions. So it is using machine learning to algorithmically to detect, even subtle patterns in the network and activity logs that may signal a possible attack, or that something is going wrong within the network or the slice that we are currently on. For example, UEBA can help detect insider threats by spotting unusual access patterns, account takeovers by identifying suspicious login activity, and even advanced persistent threats, which may exhibit low and slow tactics on their attack. And what's in for SAND5G by using UEBA? So machine learning algorithms can detect threats with greater accuracy than traditional rule-based system, especially in cases of new attacks or very sophisticated attacks. Because rule-based systems that we used to have really lacked the capabilities to identify especially novel attacks and zero-day attacks that weren't even found before. Also, real-time impact assessment enable faster and more effective response to security incidents because UEBA will immediately understand that something is going wrong and will alert the authorities or whoever the playbook says. This will help to minimize potential damage, and in a case of an attack, it can assess the damage that has happened because UBA will know, for example, this user in which devices it had access, or this device in which network was connected, and it can correlate those things. Lastly, with machine learning, it facilitates security automations, and it reduces the burden on analysts and allows them to focus more on their strategic tasks rather than trying to assess the valuation of a lot of data by themselves. Thank you very much. That was all from me.
Thank you, Mr. Katsarakis. And now let's move to our panel discussion with the title Collaboration between Public, Private Sector and Academic Community on 5G Network Security. So I would like to call the panelists to open their cameras. Mr. Hatziloizos, Mr. Koumaras, Mr. Antonios Lalas, Mr. Poulios, Mr. Vasilios Stathopoulos, and Mrs. Anna Zanakaki. So I'm going to start now asking just a few questions to the panel to get to know each other much better. I would like to first address to Mr. Hatziloizos as a representative from National Cybersecurity Authority. So my first question would be, how do you see, Mr. Hatziloizos, how do you see that 5G impacts national cybersecurity authorities? Your input to this would be valuable.
Okay, thank you very much for the question. I think that 5G brings technical complexity and new risks and force NCSAs to evolve rapidly. They have to deal with firstly with skills and personal shortage. 5G demands expertise in telecom, cloud, and virtualization, and many NCSAs still lack. So I think that there is an urgent need for specialized recruitment and continuous upskilling. As a second, I would say that there is an increased collaboration need, and to mention some of them, I would say that 5G security cuts across many sectors like telecom, transportation, energy, water supply, etc. And in addition to that, NCSAs must coordinate with multiple agencies within the member state or authorities and bodies out of it. As a third, I would say that there is an advanced compliance and auditing need. Traditional audits don't cover 5G, so NCSAs must build new tools and processes for this dynamic network environment. And the last one, in my opinion, is the legal framework adaptation. We say here that we need to produce secondary legislation to face the 5G challenges, and NCSAs must shape new policies aligned with the EU legal framework, recommendations and initiatives like NIS2, CRA, Cybersecurity Act, toolbox, etc. In summary, 5G increases the technical and strategic and regulatory burden on NCSAs, demanding from them expertise, coordination, and agility that might not have. This is my answer.
Okay. Thank you very much. Now I would like to move to Mr. Stathopoulos from the Independent Authority. Mr. Stathopoulos, I would like to ask you about regarding the security incidents in the field of electronic communications. Could you please provide us with an overview of the types of incidents and typically fall under this category, and explain the mechanisms for or channels through which such incidents are identified, reported, or made known to relevant stakeholders, especially to authorities?
Yes, okay, thank you very much for this question. Okay, let's start from the latter one, which is the procedure and the mechanism and the channels through which incidents are identified and reported to the authorities. At the moment, we have our authority has issued in Greece a second level legislation that defines a number of security requirements that providers should comply with. Also, there is a dedicated section there that mandates the providers to submit the security incident, to report the security incidents to the authorities under certain conditions. Of course, after detecting the incident, and they have to, if it exceeds a number of thresholds, they have to provide that information by creating an initial report and send it to the authority, and followed by an intermediate and also a final report. So it can be 2 or 3 reports. This is it because at the initial report, you don't have enough information to deliver, but you're just delivering the information that you have in your hand as a provider. And finally, the final report concludes all the information gathered all together and sent it to the authority. So this is the main mechanism, let's say. Of course, there are different reporting fields. I would like to mention a couple of them that's more important. These fields that the provider should submit and should fill up it in his document that it sends is the number of users affected, is the time period that has expired, that has the date and time of the incident occurrence, let's say, and also the date and time of the incident that was detected, and information related with the systems, the networks that were affected, what has happened, and also for the final report about measures, security measures that were being used in order to mitigate this incident. And the second thing that it's quite important is the thresholds. Thresholds, we mean that upon these thresholds, the providers should report the incident to the authorities. Below these thresholds, there is no need to report it, maybe because it's a small incident, but they have to just record it in their premises, maybe for a future auditing. These thresholds, in case of confidentiality incidents, which are more hot, let's say, there is no any threshold. So even if one user is affected, they have to report the incident because maybe it's critical. In case of availability incidents and integrity, network integrity, there are thresholds, and they have to report if they exceed, let's say, if I can give an example, it's after 2 hours, if 300,000 and 500,000 users are affected, they have to report it. And over the time, the number of affected users declines. So, for example, if we have an incident that the duration of it, it's about 8 hours and affected only 50,000 users, then it has to be reported. And regarding now the different incidents that we receive, as I said you, it's all these three, let's say, coefficients of security. It's for the confidentiality, for the integrity and availability. All these incidents care us. But as different types, I would say I can name about network infrastructure failures. I can name about software configuration issues. I can name like software bugs. I can name about cybersecurity incidents more related to malware and ransomware and distributed denial of service. Regarding service-specific incidents that are related to, for example, voice over IP service degradation and or SMS or MMS delivery failure, massive delivery failure. Physical and environmental causes because of natural phenomena, because of fires, because of earthquakes and stuff like that, that have affected as an initial cause the network of the provider. And also, it's very important, the third parties or their connection failures, which are also very important. Some outages may be related to cloud or to upstream providers or the power grid and stuff like that. Thank you.
Okay, thank you. Now I would like to move to the academic part. I would like to ask Dr. Koumaras. Can you hear me?
Yes, very well.
Okay. I would like to ask you, Dr. Koumaras, what are the research findings that you consider most important for cybersecurity of 5G networks, especially in relation to data protection and privacy?
Okay, thank you very much, first of all, for inviting also academic view in this very interesting discussion. I have to apologize for any background noise because I'm in a public space at the moment. I'm not at the office. I think that based on our research experience, given that we manage from a technical perspective, some SNS projects related to security like SAND5G, for example, but also in other activities related to the security, cybersecurity of the Athens experimentation platform, beyond 5G, 6G experimentation platform that we are leading. We have realized that the most important findings for privacy or security is that these aspects are not single-dimensional aspects, but it's a collection of different dimensions, security dimensions, privacy dimensions, that all of them affect the final trust level that the user experiences for the beyond 5G system. In that sense, we believe that a more holistic approach should be considered. We propose that this could be, let's say, covered under the umbrella of trustworthiness, that a system must be take many measures in different directions: privacy, security, resilience, reliability, safety, all these dimensions in order to reassure a trustworthiness level sufficient for the user in order to help him to build trust. So we have these two, let's say, poles in the system. In the one hand, we have the system that must be trustworthy, and we can achieve this by taking measures in different directions. And also, on the other hand, we have the user that tries to build trust. Having this interconnection between these, let's say, two properties, I think that it's a different view on how we should deal with security of the 5G, privacy of 5G systems, providing this holistic, let's say, approach that will help in practice to make the next step towards the beyond 5G system, towards 6G, and etc.
Thank you very much. Oh, Dr. Lalas, now based on your research, what can you tell us about what are the main vulnerabilities of 5G networks and how can they be effectively addressed based on your research?
Thank you, first of all, for the invitation of being here. So according to our research and experience in different projects, such as the network projects and the Guard AI projects related to 5G and 6G cybersecurity, we believe that one of the most critical aspects is the expanding attack surfaces. That means we need to have a variety of attack layers in the different layers of the network, physical layer, of course, transport layer, application layer. So we need to address, let's say, to provide the security layer by layer to make sure that we can address this perspective. We have also a variety of different signal protocols that introduce weaknesses. Someone may use these weaknesses to create different kind of attacks, eavesdropping and other kind of attacks. We have a variety of devices, edge devices or IoT devices that can introduce also, let's say, increased potential of attacks in the network. And of course, we have a lack of encryption in different parts of the network. That means these kind of vulnerabilities will have to be addressed, taking into account, as I mentioned, the different layers of security, the zero trust approach, but also an automated response based on artificial intelligence. Artificial intelligence, it's a very hot topic, as you may know, and can actually facilitate this procedure, can provide solutions that can be, let's say, continuously self-learning, continuously self-improving. So it's an approach that can work in a similar way, let's say, like the human. For example, in network, we follow the bio-inspired principle. That means we use an analogy between the human immunity system and the intrusion detection system, the way that the brain learns about viruses. And we can effectively apply this concept to the 5G cybersecurity by continuously learning with artificial intelligence, with new models, how to defend the 5G network. So I believe a combination of these approaches could be very beneficial to address these vulnerabilities.
Thank you very much, Dr. Lalas. Now I would like to move to Professor Anna Giannakaki. Nice to see you here on the panel, Professor. I would like to ask you, what are the main requirements arising from participating in national authorities of other countries, the project funded by the same call as SAND5G? Your expertise in this could be valuable.
Great, thank you. Hello, thank you also for inviting us and giving me the opportunity to participate to this very interesting panel today. Just to give a little bit of perspective, we're involved in a European project. It's a DEP project. It's called 5G Tactics, standing for 5G Trusted and Secure Network Services. And I guess your question is associated with our participation in and the experience we get out of the participation in this project. Now, this project focuses on the development of a 5G cybersecurity toolbox. We did hear a lot about 5G cybersecurity toolbox already by previous speakers. In 5G Tactic, we are working towards the development of 5G cybersecurity toolbox as well. Other activities that we are carrying out in the framework of this project is piloting of 5G solutions, taking specific security considerations. and performing training activities for European regulator and cybersecurity authorities. Now, we are very fortunate within our consortium to have a total of 15 partners from 7 different European countries, among which several regulators and security agencies. Apart from Greece, we also have regulator authorities from Romania and Poland, and security agents, and also Cyprus, sorry. And for security agencies, we have security agencies from Poland, Cyprus, and Romania. So we have a representation of regulators and security agencies that we work with very closely. So it's actually a very interesting experience for us, being an academic organization, learning from them what is of interest. So for me, this is a really excellent question. The framework we work with them is understanding, working closely, interacting with them in order to understand the legal framework that was mentioned earlier on. So we're sitting close with them and we try to understand the NIS2 directive, the Cybersecurity Resilience Act, CRA. So the first one refers to network services. The second one refers more to technology components and how security can be perceived and targeted for in both cases. And when we understand this, then we try to see how we can use the 5G toolbox as a framework in support of this legal framework. So we get from them high-level requirements derived from legislation, and we try to convert these into technical specifications of the toolbox we're developing. Now, this is the first level of interaction, and then there is a second level of interaction within which they derive knowledge from us. So when they define toolbox requirements and specification in order to be able to support the predefined legislation, they then need to understand the details of technology. But we can get back to this if needed. So it's a two-way interaction. We get from them requirement level. We also get from them direction regarding processes and mechanisms. And then what they ask back is to understand how the knowledge developed within the project, the technical knowledge, can be used to support certification processes for 5G equipment and 5G networks, and which will be the ultimate goal they are interested in.
Okay, great. Thank you, Professor. Now go to the private sector. Mr. Polios, regarding your opinion and your expertise, what are the main challenges facing the private sector today in the field of cybersecurity or 5G networks?
Thank you. Great question. Well, 5G is not just a faster connectivity. It's a complete reinvention of how networks operate these days. And with this reinvention comes a new era of risks. So while we enjoy the new speed, attackers are also exploiting its revolutionary architecture in ways that we did not anticipate until now. So as many already mentioned by other speakers, 5G is not just about smartphones and the speed. It's about millions or actually billions of IoT devices, from factory sensors, medical implants, self-driven cars, which are all connected real time. So every one of these devices is a potential entry point for attackers. So unlike traditional networks where the security was centralized, 5G distributes data processing to the edge. Therefore, this means that threats can emerge anywhere, at any scale. So the concern is, how do we secure a network which is everywhere at once? Then, of course, as Dr. Lalas very nicely explained, AI is transforming cybersecurity. But AI is also empowering attackers. So we're seeing AI-driven malware that adapts in real time, evading traditional defenses, tricking 5G networks, ignoring breaches. So the private sector isn't just fighting hackers anymore. It's more like fighting algorithms. So the question here is, if both sides have AI, who wins? Another challenge, which has also been briefly mentioned, is the supply chain and the overall 5G infrastructure, which is not built by a single company. It's a combination of different vendors, software providers, open source components, etc. So even a single compromised chip or backdoor to a third-party software library can risk a whole entire network. Also, considering the geopolitical tensions, again, I think somebody mentioned this, it's a matter of trust as well, not just a matter of technology. So can we afford to rely on suppliers whose security practices we cannot fully audit? So earlier was mentioned that the US have banned completely Huawei, one of the biggest providers. Then the next challenge I can see is also related to network slicing. Even though it's one of the most powerful features in 5G, it's more like a double-edged sword. So what happens if a slice that has sensitive healthcare data shares the same infrastructure with a less secure IoT deployment? How can we ensure that there's no breach from one slice to the other? So therefore, segmentation is not enough. We need to focus on isolation as well. And finally, especially in the private sector, one of the biggest problems is the talent gap. So the biggest threat is not just technology, it's people as well, and their lack of skills. So there simply are not enough experts in the market who understand both 5G complexity and advanced cybersecurity. So this is not just a hiring problem, it's an industry-wide crisis, I would say. So as a closing thought, I would say that 5G is rolling out quite fast, maybe faster than we can secure it. The private sector has the tools to respond to these threats. But the question is, once 5G will be hacked, how well we will respond and how prepared we will be. Thank you.
Okay, thank you, Mr. Polio. Now we'll go back to Mr. Hatziloizos from National Cybersecurity Authority. Mr. Hatziloizos, can you hear me?
Yes, Mr. Stephanopoulos.
Okay. The previous question had to do with the 5G impact on national cybersecurity authorities. So the follow-up question would be, how does the 5G impact national security?
Oh, very nice question. As you know, the primary 5G equipment providers and IoT device manufacturers are mainly based outside Europe, for example, in China, South Korea, and United States. Theoretically, they must comply with EU legal framework, like GDPR and IS2, etc. So, I would say that several concerns arise related to these vendors, as, for example, are they obliged to proportional legal and security provisions by their own countries? Has each member state the potential to individually identify legal and technical breaches of EU legal acts? In addition, I would say if a member state phases out a product or even more a supplier from the domestic telecom networks, what might be the consequences in terms of the related extra costs and the telecom provider competitiveness? How are these costs balanced with the expected cybersecurity benefits? Even more, what are the implications regarding the national security, for example, state-sensitive data leakage. And another one might be when an individual action of a member state is sufficient and when a collective approach is required. Finally, in my opinion, we have to answer to all these questions urgently and collectively. I think that the EU has the proper tools to release the burden from the shoulders of each individual member state and has to take the proper horizontal policies and measures for the high-risk vendors by name and by them, like what the United States do. This is my answer.
Okay, great. Thank you, Ms. Hadjilouzo, for the answer. And personally, would like to wish you, not to wish, just tell you that you're going to have a lot of work in the near future. Now, Mr. Stathopoulos from the Independent Authority, could you please provide us an overview of the underlying causes of system vulnerabilities that commonly led to security incidents in the electronic communication sector? And also, in addition, I would appreciate your insight into the best practices, mitigation strategies, or regulatory measures that could be adopted to reduce the frequency and basically the impact of such incidents.
Yes, okay. Initially, we have to define a little bit the vulnerabilities. And actually, the vulnerabilities, what we have seen during the audits that we have done so many years and what we have understood. Vulnerabilities that we have faced are all the known vulnerabilities. I mean, I would like to say from technical flaws, from human errors, from environmental conditions. It has to do with integrity protection, from malicious attacks. It has to do with anything, everything, let's say, confidentiality case or integrity case. So if I could create a hierarchy or let's say a table about that, it's the software vulnerabilities from the beginning, like at patched operating systems. It's also the hardware vulnerabilities that we have seen. It's also the protocol vulnerabilities that we have seen, just like as most of us know about the SS7 protocol, that's very weak. Misconfiguration in routing and signaling also. Other vulnerabilities that we have faced is related with network design and also configuration issue. I mean, bad or poor segmentation between network components. Also weak firewall rules under this category of network design. Also maybe misconfigure VPN services. Also causes are related to human factors that have been related also with phishing targeting when targeting the telecom stuff, I mean, and inadequate training, because people usually, when they receive an email that is weird, they cannot be sure what to do, and maybe they click on the attachments. And physical security gaps and supply chain vulnerabilities. But it's what we have understood, that it's quite difficult. Okay, at the time you're walking into the network and you try to mitigate these vulnerabilities, you always leave some part that will be not mitigated. So the first part and the first thing that we have to keep in mind according to my experience, is that you need to have a good risk assessment. Otherwise, you will never cope with all the vulnerabilities easily. And you have to apply this risk assessment in a daily by daily basis. The absence and weakness of a mature, let's say, risk assessment is the main problem. Some weak points after being identified by the risk analysis is that they underestimate usually the providers the supply chain risk, for example. I mean, they have most of the providers have, let's say, a big reliance on third-party vendors, and also this is known for the 5G that will going to be increased more. And what it required there is to apply, let's say, a comprehensive and continuous monitoring of suppliers. Ask them about create agreements between them, ask about the security requirements that have imposed to their systems and stuff like that. Another weak point is in the risk analysis is the fragmented infrastructure. I mean, legacy systems coexist with cutting edge technologies and components, let's say. So what they need to do is to find better risk assessment models that will be able to span all a new tech stacks in general. Another category that we have identified, it is a lack of real-time visibility. I mean, it's way too hard in order to have a network analysis, a network logging, and catch these logs and the events at real time. And the fix is the integration of threat intelligence, for sure, and real-time monitoring, of course. This combination, it's really helpful. Another category, it's related to regulatory patchwork with telecom operators in multiple jurisdictions with different laws. I mean, there are cases of providers that operate worldwide, and they have their culture in security, and maybe they have to be adapted somehow to the local society, let's say. This can be supported by centralized compliance risk tracking and legal monitoring. And another thing I would like to mention is the incomplete asset inventory that we have faced a lot of times. Means that the providers and even the security experts, they don't know all the devices that contained into their networks because there are thousands of. So maybe an automated procedure is required, let's say automated asset discovery and continuous update. For sure, it will be useful if they would like to, let's say, to gather and have updated all this different information about the different devices. I think this is it.
Okay. Thank you, Mr. Stathopoulos. Now I would like to move to Dr. Koumaras. Doctor, can you hear me?
Yes, very well.
Okay. According to your opinion and your knowledge, what technological trends do you see shaping up in cybersecurity based actually in your research, and how do they affect the implementation of 5G networks?
Yes, okay. I will transfer my experience from the collaboration that we have with different, let's say, SMEs, mainly in the framework of some European projects that make some open calls for experimentation in 5G, for developing innovative applications and services like the 6G Sandbox project or the Sunrise 6G or Envelope that are calling, third parties in order to test and validate some novel solution over a 5G experimentation platform. What we have realized from this collaboration is that each third party, each user, each developer has its own requirements, either if they are security requirements or, trust requirements. So each case is a unique case. So this means that somehow we must collect these requirements and map them to specific network configuration, somehow to respond to this expectation and this request. Based on this, it seems that a new trend that will also play a very major role in the security field and etc. is the user intent aspect. So through some LLM models, we are trying to collaborate with the user to collect his intent, to understand better his priorities, and to map these priorities, to specific security actions. The system to adapt, to move from an original state to a final state that will have been properly applied some configurations to respond to the user intent. So this LLM driven, so the chatbots, all this trend that currently is becoming very popular, I think that will become also a part of the security frameworks of the 5G networks and the future networks. And having collected this user intent, I think that we'll need some ML-driven or advanced AI-assisted mechanism. In the literature, we can see that some cognitive orchestrator, cognitive decision support systems gradually are introduced, which try to translate the intent to specific actions and to realize at the end of the day, to realize a user-centric network, which is specialized and properly configured for each user. So I think that the future, based on these trends, is not one solution, one security, let's say, solution that fits for all, but we need to have this user specialization, this user centric approach, let's say. Even recently we have it for, quality and etc. But now I think that we must this specialization also at the security domain. So this is my prediction, let's say, for the future.
Okay, thank you very much. Now I would like to move to Dr. Lalas. I would like to ask you, regarding your opinion, what tools or approaches do you consider most appropriate for continuous monitoring and evaluation of security in 5G networks?
Okay, thank you. As I mentioned earlier, we need to protect the different layers of the network. That means we need also to have monitoring solutions in the different layers of the network. Starting from the physical layer, we need to be able to monitor for different kinds of attacks, of jamming attacks, spoofing attacks, etc. That means we have to develop dedicated tools for this, the jamming tools, the spoofing tools, in order to mitigate these attacks, to have a continuous monitoring in the wireless channel and mitigates this kind of attacks. Also, in the other layers, we need to develop 5G specific monitoring tools. That this can be developed, of course, using artificial intelligence. Different kind of models and solutions can be applied here. We have proposed some ideas on this aspect, and this is a continuous, let's say, research topic in various projects on the field. We have also to adopt the continuous learning approach, as I mentioned earlier, self-learning, bio-inspired principles, in order to learn continuously from past security breaches and, let's say, provide defense mechanisms, new defense mechanisms, new models that are going to defend for future attacks. So this continuous self-learning approach, I think it's critical for protecting the 5G networks in the different layers of the network. Thank you.
Okay, great. Professor Giannakaki, now we get to, in my opinion, a quite important question that should be addressed to you. Regarding your expertise and your knowledge, what are the many areas in which national authorities need support to implement the results of those projects in a more effective way?
Thank you very much. That's indeed an excellent question. From the experience we have in the framework of the project I described before and interacting with regulatory authorities, we see that they develop a strong interest in getting more technical understanding of 5G networks. So in fact, we see them developing their own 5G labs, which was very surprising for me to see regulatory authorities, for example, our partners in Romania, they're developing their own 5G lab. As part of the activities of the regulator authority, they're working very closely with their own, the local national operators, trying to understand the details of the technical, of the 5G infrastructure in order to be more prepared to see how they can apply the regulation framework, the legal framework across this, and how this infrastructure can actually satisfy these requirements. So this is one part. We also see this also happening in Cyprus. So we see the national regulator there to actually developing a technical labs. They're trying to draw expertise, technical expertise out of our consortium to do that. So this is one part. The other part is getting familiar with threats, possible threats, and a lot was mentioned by various speakers today about this, so that they're trying to understand what are the various threats and the tools that one can use to identify and monitor threats. So they actually try to get a more technical exposure and perspective into this. But what is the most important, I think, trend that we see coming from various points is the fact that relates with cybersecurity information sharing. So it's not only creating platforms that will have a local kind of activity at a national kind of level, but they're interested in sharing cybersecurity information. I think this was also mentioned before by one of the speakers, trying to learn to derive lessons learned, but also notify, activate mechanisms, learn and support each other in the way that they monitor risks, they monitor threats, and they apply well-established and well-developed mitigation strategies using all these very novel tools and concepts that were mentioned already, so AI schemes and all this. So in our view, what the trend is from the experience we have with regulation authorities, cybersecurity agencies, is that they're trying to get a more technical perspective on these technologies, these 5G technologies. They try to understand from a technical viewpoint possible threats, monitoring tools, and then they're very interested into cybersecurity information sharing and if you like, exploiting the benefit of information sharing regarding threats associated with technologies, associated with services, adopting common mitigation strategies. So I hope that.
Okay, great. Yes, it covered, and actually it creates me a new question. It's a rhetorical question, whether it would be a good idea to have a 5G lab in ADAE, in our independent authority. That would be probably a good idea, in my opinion.
We're thinking about that.
Good. So it's not only a good idea for me regarding my opinion. Okay, perfect. As BNet, we would like to support you this, and of course, Ms. Zanakaki experience in this is invaluable. So now I would like to move to Mr. Poulios in the private sector. Dear Mr. Poulios, Costa, can you give us specific examples of innovative technological solutions from private sector that could improve the resilience of 5G networks?
Yes. Well, the elephant in the room is AI. I think everybody talks about AI these days, but it's true. AI is a huge advancement in cybersecurity. As in 5G, we're now deploying AI systems that don't react to threats. They actually anticipate them. So these systems analyze network behavior in real time, as Mr. Katsarakis mentioned earlier. It's in real time spotting anomalies that human analysts might miss or might take a lot longer to identify. And ideally, we need to have these self-learning systems autonomously adapt to these new attack vectors. But we mentioned a lot about AI. So a couple of other things that I have in mind is the zero trust architecture. Ideally, we should verify everything continuously. So imagine a network that every device, every user, every data packet must prove itself, but it's proof identity hundreds of times per second. So if we're able to implement microsegmentation so sophisticated that even if a hacker manages to breach one, let's say, hospital IoT device, he still will not be able to get access to other data in the same hospital. Another really interesting, innovative technological solution is the self-healing networks. So, which basically it's quite exciting breakthrough, to be honest. So, which is networks that heal themselves. So we're now seeing systems that they can detect a breach in a 5G edge computing node, isolate it, reroute traffic, and patch the vulnerability. And all of this can happen even before human teams even manage to receive the alert and join a call to discuss. So these advanced behavioral models can be used to distinguish between legitimate traffic and sophisticated DDoS attacks, which are disguised as normal usage patterns. However, here there is a risk and a decision to be made. Should we let machines take these life or death security decisions without any human oversight? It's a bit of a question here. And now a bit more future-proofing. I would just mentioned about we should consider quantum computing, although quantum computers are not there yet, breaking our encryption today, but eventually they will do. So I know that some companies have already started exploring specific cryptographic algorithms that even quantum computers will not be able to crack. And also some blockchain technology. That could also be another interesting approach. That one way to use the blockchain here would be to, for every event, to have a record that is not able to delete and disappear. So basically, at some point, if required, we can have some evidence in a court or whatever. So we know that hackers cannot delete their traces. One last thing is digital twins. This can also be quite useful. It's quite innovative as well. Digital twins, basically, they allow us to simulate attacks before they actually occur. So watch how potentially a ransomware attack can spread through the network slices, or even test how AI-powered malware could behave so that we can get prepared. That's all from me. Thank you.
Okay, thank you, Mr. Polio. Is there any question to... Okay, this has concluded all the questions that I had to make towards the panel. Is there any question that someone else would like to address to our panelists? Let me check. Okay, I have one. This actually is addressed to regulatory authority, not to independent authority, to probably Mr. Stathopoulos could answer. Mr. Stathopoulos, based on your experience in incident reporting, what are the most critical gaps you have identified in current 5G network deployments regarding cybersecurity, and how regulatory framework can evolve to better support real-time response and resilience? In a few words.
Can you repeat? Can you repeat? I didn't hear it.
Regarding according to your experience, maybe also from National Cybersecurity Authority can assist in this. Based on actually your experience in incident reporting, you are responsible for incident reporting. Are there any critical gaps in 5G network deployments regarding cybersecurity actually, and how the regulatory framework can evolve to better support the real-time response?
I think I will stay in the answer that I have given before. I mean, it's not so much related. It's so much related to specific gaps in specific points, but it's related. At the moment we have identified, it's more related to these general vulnerabilities and general improvements that need to be applied in the network. As I was previously mentioned, it's related, of course, to, for example, in the protocol vulnerabilities, diameter is also weak. We have identified some specific vulnerabilities. It's quite hard to identify it because you need you need the support of the provider, you need for the provider to let's say, to support his network with specific network protocol firewalls, very well be prepared for the diameter. So it's not an easy process if we go into specific points. But if we mention, let's say, unpatched, for example, part of the systems, which is quite often and quite general, it's more easy to approach these vulnerabilities, and it's more easy to with the provider to say to him, okay, you have to concentrate on that and you have to take measures on that. So I will stick to this answer, yes.
Okay, great, thank you. So if there are no... Yes? Mr. Hadjiloizou, yes, please, go ahead.
Yes, I fully agree with Mr. Stathopoulos. And as I said in previously, we have to cope with that. We don't be ready at this time to deal with 5G vulnerabilities per se. We are in close cooperation with ADAE, and we'll see how to deal with that. This is my point of view. This is my answer.
Thank you both very much. I do not see any other questions so far. Okay, we're a bit off schedule, but it was a quite exciting webinar with lots of useful inputs. And okay, I would like to all thank you, warmly thank you, for sharing your valuable insights on the EU 5G cybersecurity toolbox, all the innovative risk assessment methodologies, and the importance of the effective collaboration between public and private sector, and of course, the academic community. I would like to especially thank Professor Paris Kitsos, Spyros Hatzilois from National Cybersecurity Authority, Mr. Vasilios Stathopoulos from ADAE, Mr. Konstantinos Poulios, Mr. Alexandros Katsarakis, Dr. Harilaos Koumaras, Dr. Antonios Lalos, and Professor Anna Zanakaki for the excellent presentations and participation. But here I would like also to thank Rula Ioannou and Younsia Kouveli, my colleagues from PNET, for coordinating all of this, and of course, Mrs. Dido Prevedourou, our Managing Director, for her dedication to this project.
Thanasis.
Yes.
Thanasis.
I
want to say something. University of Patras, I'm Paris kids, okay. University of Patras is the coordinated partner of the project, you know. I represent the University of Patras today, so I would like to thank you also, the PNET, for the organization of this webinar. So, Rula, Dido, Dionysia, Thanasis, thank you very much. I would like to thank you also the speaker, the invited speaker, the presenters, and all the attendees of the seminars. Thank you. Thank you.
So, just a final note, keep in mind that this is the first webinar of a series of webinars. So, stay tuned, because in the very near future, we are going to invite you in much more interesting webinars with more information and sharing between all of us. Thank you once again for your active participation, and have a great afternoon, and let's keep the good work. Thank you all.
We thank you.
Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye. Bye.
Thank you.
Thank
Bye.
you all.